Hello everyone. My name is Leszek Sliwko. I founded the Axis Corporation company. We specialize in clusters, high performance computing, and this, what I want to present, what I want to share, is what come out of our recent work with the client. It's about delivery process with few caveats, so hope it will be interesting for you. So first of all, let's introduce our stack trace. Our applications are deployed on Docker, which is pretty much operating system virtualization software. The main difference is Docker and virtual machines is that Docker instances share the same kernel. So I don't have the overhead of each hypervisor starting its own operating system. All images in Docker are usually built on top of another images which are already done. The most common one is Alpine Linux, and the most common is to use the tag latest, which also updates you straight away. So that was the Docker. Our server, our cluster, is managed by Kubernetes, which is from Greek meaning pilot. It's actually quite good orchestration software. First of all, is declarative. Means you define how many pods, how many containers you want to have, and in fact it does most of the work for you. It finds the free machine, tries to allocate it, which sometimes can be consuming, depends on the cluster use. Another interesting feature is the support of secrets. In each namespace, each Kubernetes environment is called namespace, and there's a bunch of secrets which the application can use. They usually map to the environment variables. Therefore, if you start an application, you can just read from them. It gives you lots of things for free. It's automated deployment, of course, fault tolerance. It also gives you the very convenient way of updating new image when you can just roll them over. If you have like 5 containers running, it will upload them one by one. Therefore, there's no shutdown of the system. The last one is our building tool, Drone.io. It's continuous integration, continuous delivery platform. If you have seen solutions like Jenkins, you will be surprised because there's not much there. They don't have even good GUI. However, first of all, it's container native. It means it uses Docker. It's very nice integrated with Docker. It has lots of plugins. Lots of plugins, you can build Android applications, you can test them, you can load up on the image, you can deploy on that, depends. Of course, it also uses its own secrets. They can be linked to the Kubernetes namespaces, however, we didn't figure out how to do it yet. So that's for our technology stack. And now, how this works. So first of all, we have a couple of environments which I will go into this later, and each commit triggers Docker image build. Drone.io is configured by pipelines. It's basically a code which is committed together with the main application. It starts up. I will show the example of that in a second. We have an auto deploy on test environment. We have a manual deployment UAT production, which is obviously. However, the Docker, Kubernetes by itself has one inconvenience. It doesn't support templating. We have to hard code every time all the variables there to deploy in the correct environments. Therefore, on top of that, we're using something which is called KDE. It's a minimalistic Kubernetes resource deployment tool. It's open source from Home Office UK. You can use it. Everything which government does, and is not contradicting any security, is free to use. Also, we have a number of images, drone images we can use, usually for maintenance. All right, that's typical drone pipeline. You can see here it's event-based. The last line on the left is basically on every push, which is basically a commit. You can execute commands. Here we just enter in directory and compile package run. This is our image. We have a more complex script down there in Bash, which packages image on top of Linux Alpine and sends it to repository. Then another task, deploy to test, which is basically picks up this image and deploys it on test. What's interesting here? You can see here uses a couple of environment parameters. Some of them are provided by drone, some of them are provided by us when we configure them. And that's it. That's pretty hard. That's everything you need to deploy to build a pro image. It's very concise. It was everything. Right. So now I'll show you what we come up with. We have three main branches: test, master, and a release hotfix branch, which has a little bit different meaning here. Our developers work on the story branches, which they commit to test branch. Test branch is auto-deploying everything. It's creating image, it's deploying to repository, deploys automatically in the test environment. Test environment is where our testers work, and test environment doesn't have a confidential data. In this project, we cannot copy data to our system in the cluster. In this case, it's a production cluster, which is UAT and prod. Test and dev locals are not secure environments. We cannot use the local data even for testing. Therefore, the test is deployed. There's some mock-up data created inside the test environment. Testers can work on that. However, for the next step, we're merging the same branch into a clean branch, or master branch. Why? This system is integrated with many other systems, and we have difficulties to run secure testing environment for that. Therefore, our test branch is dirty. We're committing the code there. It gets auto-deployed, compiled. A tester can check for the obvious bugs. Still, there's no production data available there, or the real data. After tester finish with his testing, we do a clean merge directly to master branch. Master branch, we need to give a push. Master branch builds the images. They are called release candidates. They are clean. And this is what business testing. This is the same image which will be later moved to production. Like here. All right, and this is the novelty in this process. We're not recompiling code. The business was testing the same image, the same byte-wise image as as they have that in production. That's how it works. That's the step 3 to 4. During the prod process, we shifting images, and therefore the release candidates become a production image, and we commit to the release branch. Why release branch? Release branch is never used for building images. However, if we ever have any hotfixes, if something Haven is coming down on us, we can always check stuff from there. On average, for every 3-4 images as release candidates, one goes to production. So that's the Haven to that. Of course, those images operate in the secure environment on the production data. When business can see, test it, goes to prod. So that's our solution.